some pretty unusual and exciting work studying both the large and the very, very small organisms of the deep sea. Can you briefly talk to us a little bit about what got you interested in this work?
Yeah, that's a great question, because it's an opportunity to remind all of us that our journeys from being kids to being, adults are not always as direct as we might think, especially as kids. So I grew up in Los Angeles in a town called Downey. And Downey was a home of a bunch of aerospace companies. And while I was a kid, I loved the ocean and I loved rockets. Here's a picture of me with my parents, who are immigrants from Egypt, by the way. And this is in front of a water ride at Disneyland I was just obsessed with, right? So my love of all things water came at an early age, and my love of all things exploration. And I think that it kind of got baked into me, this idea that you could sort of spend your life studying the world around us. Now, as a kid, I didn't know that I could pursue a career in this, but I knew that I loved it. And I just found myself always drawn to the idea of studying the world around us.
When we met last week, you also described yourself and those in your lab as widget builders. And can you tell us a little bit about how that fits into the context of your work?
Oh my goodness, the lab folks, if they hear this, they're going to be like, Peter, what are you doing? What do I mean by widget builders? So, I was just telling you about how I grew up as a kid in this town where literally my neighbors were employed at these companies that built the rockets that went to the moon. And they built the space shuttle, literally. And it took all of them working together, right? From engineers to machinists to the custodial staff to human resources. It was a team, and that was very clear in this little town of ours. Today, as a scientist who loves and cares and wants to study and learn about the deep sea, it occurs to us that to do that, we're best served by kind of taking advantage of each other's strengths and working as a team, and building technologies that help us ask questions that we might not otherwise be able to ask. So, for example, if you sort of stop for a second and remember that the deep sea is cold and dark, and there's a lot of pressure, and it's very salty, and that means things will crush, metals will corrode. It's not easy to work down there. But what we do in the lab, myself and the other members of the lab, is we start by finding a science question that thrills us. How do we, for example, understand the microbes that eat all the hydrogen coming out of a hydrothermal vent? How do you do that? Well, to do that, you have to study the microbes and the hydrogen. So we find ourselves building and adapting a lot of tools to make those measurements of hydrogen, for example, right? Which is a gas and it's dissolved in the water. So we have to get it out of the water, and we have to measure it, calculate its concentration. Then we have to find the microbes. So that's the widget building. It's finding a question and kind of being willing to stick your neck out a bit and try to build something to help answer it.
So it's really a lot of interdisciplinary problem solving, right?
Yup. And as a kid, I completely remember thinking, like, why do I need to learn this? Like, it doesn't make any sense. Or why do I need to learn that? And as I got a little bit older at a time, I got to see how those things connected. And so while I don't use the heavy duty math that I learned every single day, it does pop up. And understanding it helps me design and build these really cool tools to study the deep sea.